Alright, so in the grand scheme of things, we have now effectively gotten our layer 2 core networking things in place. So we have VLANs created, ports, access ports configured in the right VLANs. We have .1Q and ISL trunking. We've got that figured out. We've controlled what VLANs can traverse our trunks. We talked about VTP, how it works, VTP pruning, how it limits the VLANs that are broadcasted across the trunks based on what switches are asking for them. And we've also talked about VTP transparent mode with the security feature of not installing VTP updates from other devices. So now we are in the spanning tree mode. Spanning tree is going to take everything that we talked about in the first 8 tasks for our layer 2 section. It's going to move us into the actual administration as to how the switch loops are prevented. So up until this point, we have configured on a hop-by-hop basis, and we've used built-in layer 2 forwarding traits of the device to build a network. At this point now, we're going to worry about spanning tree protocol, which is how multiple trunk links can potentially cause a loop in the network. Spanning tree is designed to prevent that. So, a logic review is layer 2 switches use the CAM table to switch traffic based on destination MAC address. To populate the CAM table, the following logic is used. A frame going to X, from X going to Y is received on port 1. You insert the MAC address of X into the CAM table for port 1. You flood the frame out all ports in the VLAN except for the port that it came in on. It's on a on a per VLAN basis. Now, a return frame from Y is going to X is received on port 2. You insert Y's MAC address in the CAM table via port 2, and your subsequent traffic does not require flooding. Once you have a mapping, it's basically the effectiveness of layer 2 layer 2 MAC address routing. So that's how switching effectively works. What spanning tree does is it takes a situation like this, where you could potentially have several redundant paths. So you could have this. We're just going to draw a bunch of lines here. Could all be forwarding to each other, and these guys, and you can quickly see how this would get out of control. We have all this redundancy here, where you have full duplex communication on every interface, which means that every interface can send and receive at the same time. So with all of this monotony going on, but the potential of traffic going like this very, very quickly, spanning tree was designed to prevent that. What spanning tree does is it looks at the network, and based on a set of characteristics, it determines which port is going to become the best route in the network, and then from there, it's able to make a decision based on the bridge ID, the MAC address, and the priority to determine which port or which device will become the root bridge, and subsequently every other bridge in the subnet or in the network. And then based on what role that switch plays, it's able to go in and determine on a port by port basis which ports are going to do what. So as a quick review, let's say for instance our switch 1 is the root bridge for all VLANs. Okay, so we have 10 VLANs now. So what we excuse me, what we end up doing is we configure switch 1 as the root. So basically all of switch 1's ports are considered designated or forwarding. So actually that's a horrible D. You put a D here, and a D here. These are all forwarding ports. Every port that connects to switch 1 is considered a root port because it knows how to get to switch 1 from that route. So these are all root ports. Okay, so now what ends up happening is any ports that, say for instance, switch 4 use port 18 or is using 13 to get there. All these other ports, 17 on switch 2 and switch 3, one of these guys is going to be the root port, one's going to be the designated. So depending on which switch wins, so we're going to go with lower number port or lower numbered switch is the better switch. So we're going to say this guy here is designated, this guy here is the root. Okay, so then at this point we have to determine on these two guys, this interface here and this interface here, which one of these is going to be blocking, which one's going to be forwarding. Well, by default, lower numbered ports win, So this guy's going to be designated, or I'm sorry, this guy is going to be in forwarding. This guy is going to be in blocking. So it actually would work like this. This guy would be designated. This guy would be blocking. This guy right here would be designated. This guy would be blocking. The reason for that is because the fact of we already have root ports elected, so this guy's always going to be forwarding this way. This guy's always going to be forwarding this way. This guy's always going to be forwarding this way. This guy's always going to be forwarding this way. This guy's going to forward 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 that way, and this way. Now, with all this rigmarole going on back and forth, we have two ports that are in blocking mode. What do we do? How do we make it so that these two guys aren't just in blocking? Well, you can modify switches on a per VLAN basis and say that for certain VLANs, a switch would be the root port. Typically, you're going to do this on the device where either the majority of the VLANs are created or being used, or you would do this on a switch either that is the default gateway, like say for instance switch 1 and switch 2 were the default gateways for all their VLANs. What you would do is you would say this guy is the root bridge for certain VLANs for half of the VLANs, and this guy is the root bridge for the other half of the VLANs. And then you're able to go in and do that. That would change this whole election process and change the way things are looked at. So that's where we're going to go in there, and we're going to look at this a little more in depth and try to figure this out. As you may know, all devices agree on a reference point in the network called the root bridge, which is what we discussed just a moment ago. Devices directly downstream of the root bridge perform the following. They select one upstream facing port to forward traffic towards the root bridge. This is called the root port. All other upstream facing ports are disabled and called blocked ports. All downstream facing ports are called designated ports. The next device performs the same process, selecting one upstream facing root port, repeat until entire loop-free tree is built. That is spanning tree in a nutshell. For the standards or the normal spanning tree, PVST plus, rapid spanning tree, each one has a different way of getting to that point, which we're not going to talk about. I went into a lot of detail on how spanning tree works in a previous series. This is going to be modifying this to get it to the way we want it to work. So, with that being said, what we're going to look at now is, now that the network is functioning in a stable manner, the design team has been monitoring traffic patterns in order to optimize layer 2 traffic flows. Specifically, they have found a recent increase in traffic flows through VLANs 10 and 20, with the majority of VLAN 10 traffic transiting through HQ1 and the majority of VLAN 20 transiting through HQ2 office. In order to alleviate congestion, the design team has asked you to do the following. Add an additional .1 queue trunk between switch 1 and switch 2 using port 14 on both switches. Modify the spanning tree for VLAN 10 as follows. So, this is what they want us to do for both switch 2 and switch 1 for VLANs 10 and 20, which is actually what is a good way of doing it. So actually, I didn't read this before I demonstrated this, but basically what they're saying, scoot this down just a little bit and scroll this up. Basically what's happening at this point is R1, or switch 1, is being considered the root bridge for VLAN 10. This guy will be the backup for 10. Okay, then we have this guy is going to be the root for 20. This guy will be the backup for 20. This initiates some redundancy. What we're going to do is we're going to add an additional link between 1 and 2 to provide redundancy between the devices. So actually, let's go ahead and do that right now. So I'm going to grab a console cable, or a regular cable. It's going to be a crossover because we have like devices. I'm going to click into 14. So I'm going to flip the cable over. 14. I'm going to click into 14 on both ports. Alright, so they're both up now. So what I'm going to do is I'm going to go in and I'm going to configure switch 1 and switch 2 respectively to do what it is that they've been asked to do. So I'm going to grab switch 1 and switch 2. I'm going to grab switch 1 first and do this. And I'm going to pull up TerraTerm. I'm going to hit the drop out of here. I'm going to do show spanning tree. And now we have a bunch. Now we're in rapid spanning tree, which is okay. I'm actually going to bounce out of this. And I'm going to go to global config. I would say spanning config t spanning tree mode mode is PBST. So that brings us back to just normal spanning tree. I'm going to do that for all 4 devices. I'm going to do this live. It only takes a couple of minutes. And then I can modify all the devices from there on out. Spanning tree mode PBST. Oh, PBST. Jump down to switch 3. It might have hung up on me. Pull this up real quick. Usually what ends up happening is it gets hung up like this. So it's gonna get crazy for a second, but it's TerraTerm. Config T, spanning tree mode PBST, and do the same thing for switch 4. We're gonna do a telnet to 192.168.1.64. Gonna go to global config and spanning tree mode PBST. So now all devices are spanning tree mode PBST, which is the default spanning tree type that they should be. So now we're gonna jump over to switch 1 again, and we're gonna do a do show spanning tree. So we'll do this. We have VLAN 1. We're gonna have an instance of spanning tree per VLAN. So we're going to do this, and we're going to go all the way down, and 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 all the way down. We at the bottom, this should be 777, should be the last one, and it is. So what we're going to do is we're going to go to, we're typing spanning tree. The command is going to be VLAN. We're going to type in, or spanning tree. Yeah. VLAN, we're going to say 10. We're going to say root, and it says right here we're going to make us the root bridge. So we're going to say root and primary. Remember what that does? That lowers our priority 2 full increments of 4096 from 32,768 down to 24,000, I believe it is. So we drop down here and do show spanning tree for VLAN 10. Our priority now is 24,586. That's for VLAN 10. So what I'm going to do now is I'm going to jump back up to global config, and I'm going to type in spanning tree for VLAN 20. We are the root secondary. That is what they mean by backup. So now what we've done is we've done that. So now if we jump down here, we do a show spanning tree for VLAN 20. 14 should be the root. You know what, it may not have Alright, so for VLAN 20, we're still forwarding across all of them. So let's jump over to switch 2 and do the same thing. Alright, so we have, we can modify, okay, for VLAN 10, we are the root. It says here to, on switch 1 should elect switch 1 should, okay, so for VLAN 10, we want port 14 to be elected instead of port 14. So what we do on switch 2, we go to global config, we type in interface fastseason at 0/14, type in spanning tree cost is, and we give it a lower cost, and we say instead of being 19, we give it 18. Drop down out of here, do show spanning tree, and then for VLAN 10, it should say that 14 is now the, and it's gonna take it a couple seconds for it to do that. I'm gonna jump over to switch 1 while that is in the process of doing its conversions. I'm gonna do show spanning tree, and for VLAN 10 we're designated, and this guy for the right now it is 13 is the root, so we want to modify that to make 14 the root port. We're going to go to interface fastseason at 0/14, and we're typing spanning tree cost is 18, and do the same command again, and then we're going to go and drop down again, and we're going to say for our VLAN 20 14, and it's in listening mode. That is exactly what we wanted to do. So it says verify correct layer 2 forwarding. So what we're going to do is for spanning tree, we're going to drop down to the here, and it says it wants you to check the designated in the forwarding. You give it a cost of whatever you want, as long as it's better than the cost of this guy, and then that, and then you're able to. Now it's what it says right here. It says by comparing the layer 3 ARP table on the end hosts and the layer 2 CAM table on the switches, the actual forwarding path determined by spanning tree can be verified. So it's choosing. You should be able to ping between the neighbors. I haven't tried doing that yet. That should be something I should try though. Let's see here. I forgot which ones are which. Actually, I think I can come over here and look. R5 and R2 should be. I should be able to go to R2 console into that device. Now that I have the console cable, and I should be able to get into R. I'm on R6. I want to go down to R2. Should be able to console into R2 and ping R5, theoretically. So I'm going to do a ping to 10.20.25.5. Alright, I can ping it. So we do a show ARP. We can ping that guy, and by doing that, it says right here we should be able to go to the layer 2 address on switch 1, because that's where they're connected, right? Yes, switch 1, because that's where R5 sits. Click back on here and go show MAC address table and look for port 5, and there it is. So port 5 had to respond to it, and that's exactly what they're telling me to look for. So we can actually do show MAC address table dynamic for VLAN 20, and we have 5 right there. So it is working the way it is supposed to be working, and 14 is where we're learning it from. So obviously our VLAN manipulation has been working, and it continues to work. So nice job. Should be proud of yourself. So anyway, that is how we get spanning tree to work, and that's how we manipulate the root bridge. So In the next video, we're going to talk about Rapid Span Entry Protocol and how it works and some of the ways that we can get optimization in the network. I hope this has been informative for you. I want to thank you for viewing.